Welcome to the supplementary material for the unit on variables and memory and a few other bits about extending what we did in the first week, just kind of getting a program up and running and starting to kind of figure out what we're going to do with this thing we call programming and what that kind of means in a nutshell. It's kind of our second foray into this idea of computational thinking. This week, there is some guided learning from your Zybook, and then there's going to be an assignment where we actually create a program that does a little bit more than just say hi to us. So this should this video will, after I've done recording it, will be in the week 2 overview as well, and then our assignment is the week 2 homework here, as I've named it so far. That might change, but it's in this week of introduction to computational thinking. I've got a bit of a PowerPoint, just a short slide deck to introduce a few high-level concepts for us, and we'll talk a little bit about memory and variables, and then we'll go in and do a few demonstrations on that concept. And finally, we'll get into essentially the PRIM exercise for this week, where we study that a little bit more and do a little bit more where you think about it and do a little coding in Visual Studio yourself. So that's kind of the overview for the week. Let's switch over to the PowerPoint here. Hopefully that comes up for us. Okay, great. That looks like it worked just fine. So like I said, we're going to talk about memory, variables, and programs this week. You might recall from the intro video that we have this kind of overall arching mindset for the course, where we're going to build tools. We're going to build tools that we can use to problem solve. And the ones we're going to cover this week is this concept of variables, which we'll describe in just a second. And then at the end, a little bit about input and output. I/O is what that stands for. It's what I/O stands for. And that basically means that we're going to collect input from users. Let's see here, go to the next one. So I want to talk just a little bit about memory. Memory in a computer is, and information in general in a computer, is stored with electricity. It's really just the presence or lack of a presence of electricity in a circuit, in a wire. So you could think of it like a light bulb being on or off. And as a matter of fact, that's a really good analogy, because what we use is, as we know, is called binary, which is just the simple representation of a signal being on or off. So you can think of a light being on or off, and that might be 0 or 1, or true or false. Well, it turns out that we can then extend this, and you might call this from our binary unit, into starting to count things and go from on or off, and then we could have 2 light bulbs where, we might have 0, 1, meaning the number 1. We did this a little bit in week 1, so I'm not going to go back over it, but the idea is those electrical signals are just a series of on and off signals. Well, we can take those on and off signals, and we can use, or computers do this, I shouldn't say we humans don't do this, we do it quite a bit differently, but it's mimicked quite elegantly in computers when we introduce a concept called the transistor. And that's what are in a lot of computer chips. These are memory chips on a computer. And there's millions and millions and millions of these little things called transistors. And their whole job in life is to basically store a signal over time. So they can be turned on or off, and when they're on, they have that 1 signal, and when they're not, there's 0. So the idea in programming is we can take advantage of this in many, many unique ways. One way to think about this is that we can, each one of those, I'm going to go down to another slide deck, this one, and then I'll come back to this. But the idea is we're going to talk about essentially memory getting essentially a name or an address. So like this mailbox here might be my address, the address down the road as I'm sitting here at home tonight lecturing. It might be the address of my mailbox outside my house. Well, if we think about memory as just a place to store these signals, and again, like my name might be stored here at an address called first name, where the T is in the first few bytes, uh, and then the R is in the second, and so on and so forth, right? And they're sequential. Well, what we've done essentially is we've told the computer that we're going to call this range right here a variable. We're going to call this a variable called first name. And I know that's a little small. I apologize. I was going to do this in Paint, but it wasn't working with my recording program, so I had to move it into PowerPoint. But the idea then is that we can refer to this whole thing then, this place in memory, as first name in a program. Well, the nice thing about that is that we could change this if we wanted to. I could add OR if we wanted to make a bigger one, or I could, put like if for example we had somebody named Aaron that would fit in the same space, we could put ERIN here. But the idea is that what's stored in here is referenced by this concept of first name. And that might seem a little trivial right now, but when we get into what we're going to do in just a bit, this becomes a very powerful concept because we can use this place called first name as an input for a program. And you might recall from our very first week when we introduced this box that computers do really well with this process of taking an input, doing something with it, and then producing an output. Well, the nice thing about what we can do with variables is this input then can change a little bit, right? We can just say, go to this place called first name here, and it's going to go into a process, and then it's going to do something with it. So that's kind of the concept of what we're doing, of what we're going to be doing here, as opposed to just always saying, always do this thing on this name called Trev or this number called 21. We can say, take the input called first name or the input called, it's called age, and do something with it instead. So let's see, what else did I? So, oh, and then the other thing that we'll be introducing. So this very first week or the second week here, we're going to just we're going to find many creative ways to use this, but don't be overwhelmed by some of the ways you see variables used. That'll come naturally. And I kind of like this slide because this, a crescent wrench is a very handy tool to have around the house, right? But you often use it in unorthodox ways, and that will often happen in programming too. Um, I just These tools will become more and more familiar to you. As a matter of fact, as you really kind of go through the tools here, you'll almost think of these as they play with each other very nicely. These are all building blocks, and we're going to go kind of simple, but then you'll see variables in IO used next week when we talk about if statements, and that'll be used within loops, and we'll also start to be able to then take these concepts. I'm sorry, losing my place here. I don't have the right slide deck open. Where the input becomes more and more complex, where instead of saying we're only dealing with a first name at a time, we're going to deal with a whole part of a program at a time, or we're going to even deal with entire programs at a time, and they become what goes into a bigger process and becomes the output. So that's how these things kind of build on each other. And we're going to start with what's called a procedural program here, where it's just a simple, we're going to take a simple line of code, and then we're going to expand it to have multiple lines of code, a procedure, if you will, or an algorithm to do something quite simple. It'll just be some calculations this week. But those calculations might be incorporated later in our how we build things into more complex things where they might be repeated or used in different ways, completely depending on what's going on at the time. It's really this idea of abstraction that we're talking about here, where we're going to take ideas and we're going to do them very well and make what's called a routine or an algorithm or a procedure for that, and then it's gonna go away. You can think of it like a recipe almost. Like we know how to make dough, right? We add flour and water, maybe some salt and things like that, and we do some certain things with yeast. But then that becomes a known process. Then we take that away and we put that on the shelf. And then when we want to make something a little more complex like a pizza, we bring that idea of dough back out and we say, make the dough. That's all we do, right? We know how to do that. That's kind of a known thing. We could even buy it at the store if we wanted to, which has some interesting thought processes in its own right. But then we can take that dough, roll it out, and add ingredients to it and build on top of that. That's what we're going to be doing in this course. And that's really why we introduce this idea of input, process, output. And you'll see it many, many times in my lectures here. And then that goes along with these tools here, starting with memory and variables. So with that, let's get into a little code here. Let's make sure I didn't miss anything else. Oh, I do want to introduce one other concept here. Yep, this one. So the other thing I want to do is introduce this idea of diagramming programs. These are called flowcharts or parts of flowcharts down here. And this week we're going to be talking about a sequence over here on the left where block 1 and block 2 are just simple statements. This could be print, this could be assign a variable, which we'll be doing very shortly, things like that. In the coming weeks, we'll be introducing conditional statements and loops, but you can disregard this for now. I just wanted to put this as a reference, and we have another reference on our shell here for these shapes and what they mean. But the main one I want you to be aware of this week is process. I'll come back to this though. We'll be talking about some of these other things here in a bit. So just wanted to touch on that in the lecture notes here before we get going. Okay, let's do some code. Let's do some real work instead of all this abstract mumbo jumbo, huh? I'm gonna switch over to my coding window here if you just give me a sec. Okay, so you might recall that we have done things like this. Let me just go ahead and print something here. Go ahead and clear this out just for oops, sorry. We'll just kill it. So we've done things like this, right? Where we made what we call a statement. Print here is telling us telling our computer the input is going to be this hello, right? We did this last week, and it's going to do something with it. In this case, it's going to tell Python to do this thing called print. And we can run this, and we can just do our shift enter, and as we've seen before, it does exactly that. It's trying to get that to clear out. It doesn't seem to want to do it for me. That's okay. You can see that it does that hello. And as a matter of fact, there's a neat distinction here. You might recall from our setup video that Python can be used in a lot of different ways. As a matter of fact, we can do this line by line. I can do the same thing. If you'll notice down here in our terminal window, I can print hello. So if you want to do this by yourself, that's great. If you want to do that, you can do it a number of ways. You can bring up a terminal. If you go terminal and you go new terminal, that'll bring this window up. And what you'll want is a Python shell here. I'm going to go ahead and delete this one just in case. And you can hit plus here. And I'm sorry, I do not want a PowerShell one. I want a Python one. Like, I think maybe I have to, you know what, there's another way to, in PowerShell, if you want, you can just type Python. It's actually really cool that it does that. So that is actually calling the program Python, and it's saying, okay, give me some stuff in this Python environment. And we can do this thing just like we did. You can print, let's just print something else. And we can even do some simple calculations. You can use this like a calculator. But what's going on here is all we're doing is we're giving the input to Python, and it's outputting something, right? It's the same thing that we're kind of building on up here in a more grandiose manner. But really, all this is doing is taking a file, giving it to a program, and doing something. In this case, the file is our source code up top, and it's going to this thing called an interpreter, which is what Python is on our computer when we installed it, and then it's giving this output in terminals. We'll find many, many different ways to get input and output into and out of programs, but the analogy remains the same, and it's quite elegant. So I'm going to actually change a little bit here, change modes. And let's say we want, I've kind of given away what I'm doing here, but let's go ahead and say I wanted to do a calculation and I wanted to know what, what, uh, let's say we wanted to know something like, we want to know what 60 degrees in Fahrenheit, oops, sorry. We want to know what 60 degrees in Fahrenheit would be in Celsius. Well, it turns out that you can do that calculation with this formula. We can learn this from our friends down the mall here in our physics department. This is how we do it. We just trust that at this point. We're dumb computer scientists. We don't really know this outright, but we can write programs to encapsulate information. So this is the kind of the number we want to convert. Let's say it's 60 degrees outside, and I certainly wish it was here in December. Well, we can run this, and you might recall we can highlight things and hit Control Enter sometimes, and it will do this calculation for us. And as a matter of fact, it did that. It would be 15 degrees Celsius. So 60 degrees Fahrenheit is 60 degrees or 15 degrees Celsius. And we can even type that down. Oops, sorry. I was trying to get this to copy paste, but it doesn't seem to want. Let's see if I can get it. Sometimes it's a little finicky. Down there we go. I did that by right clicking if you're curious, and it will give us the same information. That's great. You know, that's a really nice way to kind of start with a program, or start with using Python to do some things. But we can do a little bit better, and this is where programming gets its word programming. What we can do then is we can, instead of saying only work for 60 degrees ever, we can write a couple statements. And this is where we're going to introduce this concept called variables. This right here is a named address. If you recall back to the PowerPoint, let me just go back there for a sec. Just going back here, we have this first name. Well, we have the same thing here in Visual Studio. Let me go there one sec. Where we're creating an address, you can think of an address on a mailbox called 50. And what we're doing here is we're putting this value called 70 in there. So you can think of user input as a mailbox, and it says, go there and grab whatever is in there and grab this thing called, or the value out of it, in this case is called 70. Well, the nice thing about that is we don't have to put 70 everywhere. Because if I wanted to like do this where I'm printing this thing out, things like that, I would have to put 70 here and here, right? You can even see the program kind of telling me what's going on, and we could do that. I'll go ahead and do it, and then I'll undo it just to illustrate it. Oops, just like we did before, we can put it there, we can put it there, and we might get something, where we run line by line here, where it's prettier. It says 70 degrees is 21.11 Celsius because we did some formatting here, right? But instead of doing that, if we use variables, what we can do is only input it once. So say I wanted to change this to 100 degrees. Well, because I've got this variable, first it's going to assign this. And let's go and do this down here, actually. Let's go and do this in the console one by one, and then I'll run it all at once. So first I'm going to assign it. And this equal sign here in Python, the single equal sign, I want to be very clear about that, because there's the double equal sign does something different that we'll talk about next week. But the single equal sign takes this value and puts it in this variable, in this address, right? So we're going to go and do that. And that's done. It didn't look like it did anything, but it did. It put this into there. And it's always from the right to the left. So your variable name always goes on the left side, and then you have the assignment operator, the equal sign, the single equal sign, and then its value. Turns out the value can actually come from other programs, which is quite elegant, and we'll see that here in another example in just a sec. As a matter of fact, it's going to happen right now that I think about it out loud. I'm going to copy this now, and I'm going to put this down here, and we have a slightly different bit of code where we're taking the thing that was in user input and say, go out and grab, in this case, 100, subtract, and do the rest of this math, right? Order of operations and all that are in play here. And then it's assigning that to another variable. So again, the thing that happens on the left goes in, or on the right goes into the thing that happens on the left. In this case, we're creating a new variable called converted Fahrenheit. And I'm going to go ahead and just hit enter here, right? And then lastly, we're doing an output format. So this is kind of what we did in week 1, where we just printed some stuff out, and we studied F strings a little bit. That's all that's going on here. It's just formatting this pretty. Plenty of material on that. I'm not going to get into that in this lecture. And it does our nice little print job. Well, it turns out that what we've built here is actually a program, a sequence of 3 statements that do things that are related to a task. In this case, it's taking an input, doing some math, and printing it nicely. But because we've done this thing called abstraction, where we've taken the concept of here's the input and storing it someplace, and then doing those operations on variables, this becomes what's called modular. We can change this in one place, and things happen to change everywhere else. So if I run this, again, I'm just doing Control Enter to do that. I'm sending it down to the Python interpreter, is all that's going on there. I could do -10, right? Figure out what that is. So we've built a little procedure, program, algorithm, kind of synonymous in all these things, to do this thing, right? That's what's going on here. And then once we've got that down, we could maybe go the other way. Let's say we wanted to do something like, let's instead grab something a little more robust, right? Where we do something like this. I'm going to actually, remember, we can comment out code by using these three quotes above and below code we don't want. It basically makes the computer think that this is just we're writing to ourselves. That's what this is doing right now. But what it allows us to do in this case is we can run this program like this, where we run the whole file. And the nice thing about doing that, I'm going to go close this for a sec, is because this is expecting input, it's going to wait for us, and we'll see that. What I did, let's see, I broke something. Oh, let's just close that. Let's do, there we go. It's basically going here, and this input thing, it's another one of let's go back here, just a sec to power our PowerPoint window. Where did that go? And if you recall, oops, sorry. That's all we're doing here is a different kind of program where the ifs or the input statement saying wait for somebody to actually give us an input. That's its input. It's like print something out and wait, and its output actually becomes an input to another program. I know that's getting a little philosophical here, but it's kind of cool once you kind of start to put that together, how you can chain these things together. Hence the term tools and toolkits. Anyway, back to code. Sorry, getting a little ahead of myself on a few things here. So let's go back here. Get back here. So when we run this, we can actually have the user do this, right? Where instead of running code, we can actually just run this program and do the exact same thing we've been doing. So we can start to extend these things once we understand, like, okay, we know that something like this works. Well, then maybe we can extend it. So instead of putting the variable in, we can extend it to have people put things in. And what's going on here, just technically, is first, Python is going to print this out, this text, and then, like we saw, it's going to wait for the user to put something in. And then what happens with this float is that float is changing text, or attempting to change text to a number, so it can do the calculation. So for example, I can't divide the name Trev by 4, right? That doesn't make any sense. So if somebody put Trev in there when asking for the temperature, it would actually just say, and then if you tried to do math on it, Python would say, nope, I give up, user error. So that's what we're doing here, is saying, okay, first you have to take what's called a string and convert it to a number, or a decimal point in the case of a float. and then store that as an input. And that allows us to do things like that. So if you tried to do this without float, you might see something like a conversion error type error. Well, let's actually just see what the error would be, right? We can play with this real quick. No reason not to. It's, computer cycles are cheap. I'm just gonna kind of clean that up, and we'll just kill you and play you. And the error is could not convert string to float. So if you run into that, that's exactly why. Is it's trying to do math on a string, and it catches that before you even do it. So I'm just going to go back here and like so, and then this should just go back to normal where we can put numbers in, right? And we get those. The other thing it can do, or that I want to demonstrate is if I did put my name in here, we'll get an error very similar, right? Very similar error. So just a good way to get familiar with some of those things. All right, so this is kind of the idea of building what I'm calling a procedural program this week, where we take things and we start to combine them and store things in memory in variables to do operations on them. The recipe analogy is a good one where we start to build things and modularize them. We'll come back to this concept because it turns out we can tuck away code in a lot of really cool ways in programming that start to let us do many of these operations either on a lot of data or in different ways or in different formats. It's really this is just really the tip of the iceberg. If you can maybe think of this as a nail and a board, we're going to introduce hammers and saws and things like that to kind of play on our toolkit analogy here in a little bit. Okay, so just a little bit more about the assignment this week. You'll read about all of this stuff probably before you've watched this video. And then what I will have you do is we will go in and you're going to, right at the end of the reading, kind of do what we just did in this video. All I want you to do here is predict what's going on and then run it. That's all we're going to do and predict. So open this up, kind of read this code, take a second and say, I think this is going to do this or that or the other thing. And then be honest with yourself if you got it wrong or right. The point of all this is to take a second away from the code, just think about what's going on. And then we're going to investigate it a little bit. And you're going to run this and you can play with this a little bit. This one takes a little bit of input. The next one is I'm going to have you modify this to add a few different calculations in the same way, and we'll do some printing here, and we'll see that we convert things back to strings. So this is all working code, and it's stuff you can build on. Maybe you add 10 to it or something to that end, things like that. And then last we get into our assignment. The assignment's pretty straightforward, where you're going to just basically calculate the volume of a cylinder. Honestly, you have everything you need to do that right here. And then you'll write the program down here, and maybe with a little documentation, either you can replace this block, or you can just say, you could just start typing down here by and explain what you did down there. Or you can even grab Paint or another program and start flowcharting it. That's perfectly fine too. And then finally, you'll package up those files and then submit them in Canvas. I think Friday night is going to be our due date for this next term. So I can grade and get feedback to you over the weekend, and we can move on. So the idea is that you'll get feedback on your previous assignment early in the week, right after you've done your reading, so we can course correct if things are going on. And that also gives our asynchronous folks a little more bandwidth to maybe have a chance to get a hold of get a hold of me certainly, or other classmates during the week when we're a little more active. I'll be monitoring the boards though, so do your reading the week before, right? Our work week, for lack of a better term, will be Saturday to Friday. So do your reading on Saturday. Hopefully it's a little lighter, and then the stress should come during the week, and hopefully we turn things in by Friday for this part of the assignment. So that's kind of the unit on memory management and variables, and this introduction to what is a program and an algorithm. A topic we will visit many times. Good foundational piece though. Really want you to get your sink your feet into that kind of concept. Maybe think of some applications. We'll have a discussion board post this week as well, as it relates to the final. But certainly let me know if you would like to discuss this further in the open office hours or anything like that. Thank you.